Here we're asked to integrate the function cot x over 5. So we might remember that whenever we have some constant factor, be it a whole number or a fraction, positive or negative, we can extract this out of the integration. So what we can do is we can rewrite this and take out that fifth to give us just cot x in the integration. Well, we might also remember from trigonometry that the definition of cot x would just be cos x over sin x. Now, thinking about the ideas of using a natural logarithm for the function that happens to be in the denominator of a fraction when we're integrating it, well, if we think about sin x and the differentiation of sin x, does that help us with the numerator? Well, we can just test to see if that's true. Well, when we differentiate sin x, we get cos x. So using this principle above and trying to think about what we're going to let y equal to, we could let y equal, and we're going to have a natural logarithm of the denominator. Well, if we try to differentiate this, we're going to have to use the chain rule, obviously. So whenever we differentiate natural log, we get a 1 over effect. So the function happens to be sin x, so it's 1 over sin x times, remembering the chain rule, the differentiation of that function within the brackets, which just happens to be cos x. So we find that this equals cos x over sin x. Or, in other words, cot x. So we realize that if we were to integrate cot x, we would return back to this original function. So we can write this conclusion . However, the original question did involve having a fifth, which we can now reintroduce back into the original function. So if I multiply the left-hand side by a fifth, I'm going to multiply the right-hand side by a fifth. And we shouldn't forget the constant of integration, because this is indefinite integration.